When we talk about velocity, what is it that we're talking about? What does velocity mean? Well, we're talking about the distance that you travel and the time that it takes to do so. We're also, when we're talking about velocity versus speed, talking about the direction. But if you're talking about the magnitude of velocity, it comes from the distance that you've traveled in some amount of time. So, if we have some positive x direction here, if this is our x-axis, and this is the positive x direction, then we can have some initial position here, we'll call it x1, at some initial time, t1, and we can have some final position here, x2, at some final time, t2. And so if we're talking about some object, say car, that's traveling this distance, it starts at x1, and it makes its way at some to some x2 in some amount of time. So, to find its average velocity, we would take x2 minus x1 and divide that by t2 minus t1. And we can write that simpler with this delta symbol, which just means the change in x divided by the change in t. So the displacement, the amount of distance covered, divided by the amount of time it took to do so. And the units, you'll notice, also work out. So if x is in meters, the distance is in meters, and the time is in seconds, we have meters per second, which is standard velocity units that you see often in physics. So this is average velocity. It may have been going faster or slower between points x1 and x2, and we would not be able to find that out simply by taking the 2 points. But it gets you average velocity. And notice what we did in order to explore this situation where a car starts somewhere and ends somewhere at a different time and position, is we chose a positive x-axis and we chose an origin. So this here is the origin, and we said car will probably start at the origin. We could have had the car start, somewhere here, but it just complicates the problem because then you would not get to use your x1 and t1 as at 0 or one or the other. So it's helpful to have your thing start at the origin at t equals 0. So one way that we can explore what's going on graphically with this guy is by making an xt plot. So if we have an xt plot, then what is the slope of the xt plot? Well, the slope should be velocity then. So if we have this axis here as x, that'll be in meters. And we have another axis here, and that'll be time in seconds. We can plot 2 points that correspond to x1, t1, and x2, t2. So let's say our 2 points are, so P1 is going to be 0, 0, and P2 is going to be 7.9 seconds and 402 meters. Well, if we were to plot this up, 0, 0 is here at the origin. 0, 0 is here at the origin. So that's our P1. And let's call this 8 seconds. Let's call this 400 meters. So then our P2 would be just shy of 8 seconds and just above 400 meters here. That's our P2. So the line that connects point 1 and point 2 here gives us the slope of our average velocity. So the slope of this equals V average. Now notice the actual path of the car, because this is V average, the actual path of the car could be something like this. But it does pass between those 2 points. And so instantaneous velocity, which we'll talk about next, would be the slope at various points along this line. You would take tangents. But for now, we just have our average velocity. And so to find this average velocity, other than measuring the slope, you would just take V average is equal to delta x over delta t, which is the distance traveled is 402 meters minus 0 meters, our initial, divided by 7.9 seconds minus 0 seconds, which turns out is something close to 51 meters per second. And these numbers are accurate for the car that I brought into the picture earlier, that Ferrari Pista. And that turns out to be an average velocity of about 112 miles per hour. And 402 meters is an 1/8 mile. So in an 1/8 mile, the average velocity of that car is 112 miles per hour. Incredibly fast. All right, see you in the next video.